Joining us for today's Open Generation Government Liaison Roundtable. My name is Brian Zelli, and I'm here from McLean, Virginia, at MITRE Engenuity, where I manage the Government Liaison Program. OpenGen's Government Liaison Program allows a dialogue between members and government leaders who are also stakeholders in 5G and our use cases. And we prepared an interesting discussion for you about how the Federal Aviation Administration is approaching communications for UAS operations. Today, we'll be talking to Art Hinaman and Chris Nassif of FAA's UAS Integration Office. Art is the manager of the Technical Programs Branch in the UAS Integration Office, and he has extensive UAS and aerospace operations experience. Chris is a program manager in the branch, and he has many years of test and evaluation as well as UAS experience. So I would like to note that this meeting will be recorded. And after Art and Chris give an overview of their thoughts on UAS communications, BV loss operations, UTM, V2V, 5G communications, we will open the floor up for an interactive discussion. I do ask that you please raise your hand and we will recognize you to ask a question, just to keep it organized. I've also encouraged Art and Chris to ask questions to you, our industry and academia members, of their own thoughts, for your thoughts of what lies ahead in the intersection of UAS and 5G communications. So with that, I'm going to turn it over to Art and Chris, and please go ahead.
All right, thanks, Brian. I'll go quickly, then I'll pass it off to Chris. As you mentioned, Art Hinaman, Chris Nassif, we're in the UAS Integration Office in the Technology Programs Branch. I'm going to give a little bit of a high overview of what we see as the use cases for 5G. And Chris is really our guy deep into the technology, working some partnerships and testing, and he can talk about some of the stuff that he's doing. And we'd like to spend probably more time in dialogue with folks rather than us just kind of spitting out things that we think are important. We'll give you what we've got up front, and then hopefully enter in a good dialogue. So I'll start off with so we see the use cases, and I think we've talked about some of this stuff before, but the obvious use case that jumps out at you is command and control of unmanned aircraft, both within visual line of sight, but even more importantly, beyond visual line of sight. As we get into the next phase of UAS integration, it's really beyond visual line of sight is what's going to make some money for us. Along with that, UTM connectivity, that's probably going to be one of the big building blocks to enable beyond visual line of sight operations, and in V2V, vehicle to vehicle communications. With that, we're looking for 5G, cellular in general, but 5G even more particularly, to give us the strategic deconfliction and tactical deconfliction. Strategic deconfliction would be coming with intentions filed in a UTM network, or that tactical deconfliction would come from V2V, keep aircraft from hitting each other. Actually, that's the use cases that jump right out as initially. I'll turn it over to Chris to introduce himself and talk a little bit about the partnership that he's got going on and some of the testing information. So, Chris.
Thanks, Art. As already stated, hi, Chris Nassif. Been in the government for about 18 years now, plus, I think. Most of my career has been spent in UAVs, test and evaluation, counter UAS, things of that nature. So my main focus in this office right now is looking at the cellular modality, the capability of controlling UAS nationally via the existing cellular network. To that end, over the last few years, and a lot of you were probably involved in this as well, was the development of a set of testing metrics that could be universally used here in the nation and internationally, so that anyone who is a UAS operator that wants to explore this capability knows what type of data they should actually be collecting to determine both the capabilities and limitations of their operation. To date, it's pretty much focused generally on 4G, LTE, those types of technologies. We haven't really jumped into 5G yet, but we do have a single metric that is attached to our larger portion for all the operators to be able to use. And to help scope this a little bit, I actually have, a couple slides on a previous brief that I've used, and then I can flash up the metrics as we are currently using them. That will kind of scope our discussion here a little bit. And I think this allows me to share screen here. So, whoops, keep popping open Windows. There we go. If this goes into its slideshow, which it may or may not. Okay. So bottom line, a lot of people are exploring CMPC usage right now for cellular. There's at least a couple dozen companies. The main one of which that we're working directly with in a partnership between the FAA is with Skyward, which is underneath Verizon to explore these capabilities. And to date, and this is since October, they have been testing all over the country. We have hundreds of hours of data marking all of these data points. I think we're up to about 300 pages worth of testing data. And it's not fodder and it's not fluff. I mean, this is actual, ground pounding work where we're determining what the network can actually handle with aircraft operating in different types of environments and different types of capabilities. For those that aren't aware, I mean, when it comes to UAS usage of the cellular network, we're not looking at leveraging really the main lobes. The main lobes are approximately 100 feet below as far as where they are impacting the ground. And obviously there's ground path propagation that gets a little bit more distance. But for the most part, UAS are leveraging the side lobes, the incidental energy that is emitted from cellular towers up at altitude. Some studies have shown this going up above 10,000 plus feet AGL. For the most part, we're talking about Part 107 operations in our testing. And some of the other work that we've seen come out of groups like TIOCO, the slide that we have up here from Airborne RF, where they've been collecting data looking at the huge problem with it. It's massive number of handovers going between tower to tower all over the place. We've had some flights that, in only 2 hours, it had over 300 different turnovers, handovers between towers. That's because, once again, you see on the previous slide, you're hitting all of these side lobes. Whoops. Was someone talking? Oh, okay.
No, go ahead, please.
No worries. So in the end game, disregard the aspect here for like GA or other aircraft above it, but is the cellular system able to handle 10 million UAS flying around the country? And that's what we've been trying to solve in these cooperative agreements that we have with different programs. And it is not just this program, but it is also work that we do through our partnerships, our PSPs, things that we attempted to do in IPP, things that are being done and beyond. All of these companies are really starting to look at the cellular modality as far as UAS command and control, because in reality, that is kind of the only existing network right now to get beyond visual line of sight, because it is a licensed frequency that can handle those distances. A cell phone is allowed to put out more power than a Part 15 device, therefore can typically achieve greater ranges, especially with whatever you do with it. And then with that, these are the metrics that we have been using. Again, many of you on the call were involved in the development of this. I thank you very much for your help. So far, I know of at least 4 different groups that are using this. One of them is required to provide us data sets. So we do have that. Unfortunately, I can't share with you any of the results from it yet or the actual data due to NDAs and the proprietary nature of the information, but we are working with their legal to get to the point where, and this is the purpose of the program, to share that information with regulatory groups like SC228, RTCA, so that we can develop new standards, new regulations. I mean, to date, there is only one piece of legislation, Part 107, that states what UAS can and cannot do. What if we actually had regulations that said specifically, okay, here's the C2 that we're actually looking for. Here's the network capability that we're looking for. And it touches a lot more things than just C2. But I won't go through this line by line. A lot of you are very familiar with it. And this is publicly distributed. Anyone that does not have a copy, I can ensure that you get one. But what we have on here are 14 different metrics. And these are recommendations on what to test to. They are not requirements. They are not guarantees of a waiver. What they are is a great accompaniment to a safety case while we are still in the age of waivers and exemptions before we actually have regulation for these types of aircraft. But all of this information, it just kind of goes through saying what the metric is, the definition of it, and why we're actually asking for it. And a lot of it really is common sense information. Where are your towers located? What frequencies are you operating on? To try and give us an idea of what the UAS environment looks like. Is the US network as it exists capable of handling this, or does it need to be modified? Now, again, these metrics are written for the purpose of 4G LTE, not really taking into account the advanced capabilities of 5G, but you still have similar types of propagation patterns, towers at, nominal heights, between 75 feet and 150 feet, 120-degree arcs spanning 360 degrees, and most importantly, the leveraging of side lobes. We probably expect that 5G will be deployed into urban areas first, and you'll have more microcells in the type of area where you'll have more cell phone towers in a more condensed area. How is that going to impact leveraging side lobes when there's even more overlaps? So a lot of that data, it's still being learned. We are in the process of it. And I'm trying to find the button that says stop sharing. There we go. So back on full screen here. But we are learning quite a bit. We've actually already seen quite a few lessons learned and learning what happens to things like the RSRQ and the RSRP once you breach the horizontal plane of the main lobe that comes off of a cell phone tower. And when you transition into the side lobe area, we're also seeing a lot of things that relate to the orientation of the antenna. For most UAS, your control antenna is on the bottom of the aircraft. When you do a hard bank and you no longer have line of sight to the tower you're connected to, how does that impact the hard handover to the next tower? So a lot of things like that. And I will say from our end, and posing more of a request than a question to the group, is you are the experts on this call. You are the ones that are actually conducting this work, have built these towers, understand this technology down to its nuanced level. We are starving to find as much information as we can, because getting it from one source, especially one of the main MNOs in this country, is fantastic. Ideally, we would like to see it from all of them so we can actually compare data and see how connectivity changes as the band changes, as the power output from the tower, as the orientation changes. So as many data points as we get, that allows us to kind of really get into big data theory, where we can see what the whole of the network can accomplish, so that one, it will feed regulations, and two, it will inform UAS operators in flight path planning. Where should they operate? How should they operate? So we are getting there, baby steps. I apologize that I don't have any of the real tangential data that I can share with you here today. But hopefully in the next quarter or so, we will be able to present that on a larger forum for everyone to be able to use and help out with their own testing. And that's what I have.
Yeah, thanks, Chris. Let me just leverage off something you just said. It made me think, as far as partners in this testing and sharing data. So we have a partnership with the FCC and NTIA. We meet with them monthly, and we're working this together. We in the FAA, obviously we're interested in safety of the National Airspace System. FCC is mainly concerned about interference and the operators, the people that are paying for this spectrum, to be able to use it without interference. So we're interested in the performance. Will cellular, will 5G give us the performance that we need to safely operate unmanned aircraft? FCC is interested, can we do that without interfering with the people who are paying the bills? So the more people we can get, the more good data we can get and share, develop standards, the sooner we'll be able to use this technology, on a larger scale to command and control unmanned aircraft.
Well, Chris and Art, thank you so much for the intro. Fascinating things there. I'm especially fascinated by the use of the side lobes, which in many times in radio energy, that's unwanted energy going off a direction you don't want it to. But here we can actually take advantage of that. Kind of unintentional radiation becomes very beneficial when it's going exactly where the US are flying. So I guess maybe you've already answered this. So what testing requirements do we still need? I know you're building out the spreadsheet and everything, but I guess what operational data would really help to inform the good regulations that you're striving for, especially in the beyond visual line of sight field?
Great question. So it's a great set of data points that we have right now, but it is, of course, a living document. As technology changes, we need to keep up with it. So 5G, I mean, with its higher bandwidths, higher power, their new technologies allow for a lot more metrics to be added to this for us to try and be able to understand what can and cannot be done, between splicing, the microcells, things of that nature. And I kind of rely on people in this group to be able to help work with us and determine what metrics do we need to add to this to also cover 5G as that technology is changing, as new opportunities. I mean, is 5G going to be better for UAS connectivity? I mean, we all know that it can hold more bandwidth, so it's going to be greater, obviously, for things like DAA and capturing visuals, 4K videos, things that are high bandwidth and would normally saturate the network. Art touched on this, and I forgot to mention earlier, the 14th metric was written by the FCC and is primarily focused on interference. So one thing we do ask is when people are doing all of these operations, work with an MNO so that you do understand what the interference basis is to the terrestrial user. I can tell you that in the Skyward program that they're working, every time there is a flight op going on, there is a team back in their home office in Portland that is monitoring in real time to see if there is any interference to the local network from that operation going on. And I can happily report today that there has been zero. Granted, we've only been doing 1 and 2 ship operations so far, but as that expands, things will change. So yes, again, as far as what new metrics, I don't know. I would need to hear from those that are working in the 5G technology for what they believe are additional metrics. And we are happy with consensus of the group that originated this to add that to it. Again, these are recommendations that we put out there, so we're not too stingy about what we add to it. The more information that we can share around this community is obviously the better.
And I'm curious, along those lines, there's maybe somebody out there that has some thoughts on it. But with that, maybe a metric is, if we can measure the saturation and the handovers, now that we're operating at altitude and not at ground level, we're seeing a whole lot more towers, and sometimes randomly, it's hopping from one tower to the next, and don't know if that's a good thing or a bad thing, or it doesn't really matter. But just some thoughts on how we can handle all this saturation, handovers, or is it a problem we even need to address? We just live with it. Maybe it's not a problem.
Yeah, I also wonder how terrain affects that too, where it might work really well in a flatter area, but then you get in the rolling hills of the Northeast or the mountains of the West, and it might change considerably as well, depending where the towers are situated.
I can actually answer both of those questions real quick, if that'll help.
Oh, sure, please.
Handovers, massive, lots of them. Once you leave the main lobe and you go into the side lobe area where you're above, 125, 175 feet, that's when you're hitting the side lobes. Lots more handovers. To date, we don't see any issue against the network with that. As far as terrain, you need line of sight. When it comes to the side lobes of a cell tower, you need line of sight. Main lobes, they're able to get away with bouncing off of buildings and trees because you are on the ground. That is the main emission of the energy. But just like most C2 that is used to direct any aircraft, once you're up in that area, if the aircraft cannot see the tower, it's not going to see a C2. Luckily, once you get up to those altitudes, you have almost a 20, 30, 40 mile slant range, and you can usually get at least a few cell phone towers in that.
Thank you for that. I just want to open up to everybody on the call. Please feel free to ask questions. Use that raise hand function if you have any questions. Lots more to talk about, whether it's V2V or dive more into these issues as well with communications. Layla, I think you might have a question ready.
Yes, thank you, Brian. So no, I wanted to when you were suggesting that we come up with additional metrics or additional, let's say, information that would be relevant, just so we understand the scope of the information that you were referring to that you already have, Chris. Is this mostly LTE metric, let's say data related to LTE networks. Is that what it is? I'm trying to see how much 5G related information you have, and if that, I mean, looking at 5G and how it compares with the LTE would be part of the, let's say, area of interest.
Muted, Chris.
Sorry. All the metrics that we have so far were written for 4G LTE.
Okay.
So we have one that was added on at the end, a little bit into 5G, but nothing else has breached into that. So as those that understand the technology, I would love to see if there are additional metrics that are unique to the technologies associated with 5G.
I mean, either that, either they could be new metrics or the same metrics, but how the performance on those metrics is different. Maybe, sorry about that.
It could be separate
With
or
5G,
it could just
yeah.
add on to it. I mean, it could be an appendix to the original because cell phone technology still generally operates the same way as far as emissions. They were talking about earlier about side lobes and how that works. I've been dealing with side lobe emissions since I was countering remote controlled explosives in Iraq 11 years ago, and that's how we learned about their capabilities and how they affect systems. So that technology remains as a matter of physics. I'm very interested in the new technologies that 5G have enabled with its higher bandwidth, higher power outputs. If that is turning us in a direction to where maybe the metrics that we're collecting are good for a baseline, but then there are additional ones that we should collect through 5G.
Understood. Yeah, and I mean, on the technologies on 5G, thinking of things that we could be doing in experimentation that could demonstrate that some of the metrics that you have already highlighted could be, let's say, improved using, for instance, things like let's say network slicing or some different methods to mitigate interference and so on. So just thinking that that would also be, just to confirm that that would also be of interest. Is that correct?
Absolutely. You know me,
Okay.
I'm interested in everything.
Okay.
And Layla, that was the next thing I had on my list here. Is I'm interested in hearing the people who are smart on 5G, how the attributes of 5G can actually enhance the safety of the NAS. Things like the network slicing prioritization. You know, we look at our most primary concern is that we have good, reliable command and control. But then also there's probably plenty of bandwidth out there in the cellular network for payload. So, you know, video and all that. And then how do we prioritize you know, you get your payload until things get too busy, then you lose your payload. Or now we got to factor in cell phone usage also. So where does me talking to my mother fall in the stream of priorities of the video of the houses or the command and control of the unmanned aircraft? So we're interested in a lot of that kind of stuff. How can the attributes of 5G enhance safety of the NAS?
Perfect.
Charles from Drone Responders, go ahead with your question, please.
Yeah, I lost you there for a little bit from connectivity, so I'd just like to have 4G everywhere first. Just joking, but on the 5G side, I think that, and you may have covered this already, and you hit on it a little bit ago. From a public safety perspective, command and control is of course important, and then we're also concerned and curious to see how the transition goes if you lose 5G and you're going 5G to 4G. Is there a transition that can make that work? And then the second piece is it's really about the data from the remote sensing. So it might be video, it might be hazmat detection, it might be LiDAR, and then the multiplicity of that and identifying locations of personnel on the ground and pulling all this together. So it'll be interesting for us to see how this all works out from the capabilities that 5G allows us to do, kind of this multiplicity of data.
That brings up a really good topic then too. As we talk about prioritization and network slicing, at some point maybe the payload is more important. If you're actively monitoring a dangerous situation, and the aircraft is pretty highly automated, that it knows it's going to stay where it's supposed to stay. Maybe it's more important that you're that you're hearing from your sensors than it is that you have C2 of the aircraft. So, and dynamically, how easy is it to change that on the fly, literally on the fly?
This is
Yeah, and I think
something-
the back as well now as the indoor flying with law enforcement, especially clearing rooms or monitoring hazmat situations.
This actually plays a very large part, and this is another discussion for another time, but when talking about BV loss, that's when we transition from the fact that CNPC is not as nearly as important as the DAA information that the onboard automated systems are using, and to be able to downlink that to a GCS. So the bandwidth increase that 5G allows to get us to that point where now payload information can be downlinked, that's where the safety cases are going to be in the future. It's going to be a combination of C2 and DAA rather than just reliability on just C2, where the DAA is usually accomplished by a visual observer or pilot in command. So I would be very interested in learning what the bandwidth limitations are for 5G. And taking into account things like attenuation or how well propagated the network is, because that is a question that I ask on my programs all the time. What can your network handle if we're operating on 900 megahertz? Can I do 4K video? Can I do a DAA acoustic or visual system? What can actually be brought down there without interfering with the terrestrial system? So that's why we are baselining right now of the network of having these aircraft up there using the C2 to determine where it is effectual, where it is not, and then boost up the amount of data that we're transmitting over that to see what the saturation level is.
Before we get to Tom's question, just a quick follow-up on that. So also, what happens as the bands change, whether it's, moving from a millimeter wave cell to a mid-band cell, or if it's falling back to LTE instead of 5G, how does that impact that scenario as well? Tom from CTIA, go ahead with your question, please.
Yeah, thanks for sharing, and a bit of a comment and question. So with regard to 5G, I think you're right, is you're going to have potentially more spectrum available, so wider bandwidth. Power levels are not necessarily higher. You mentioned, I think, a couple times that you have higher power, but similar power to what's going on in 4G. I think the industry folks could help to update a matrix similar to what you have today for 4G. But you should also be thinking about, 5G's going to have these different frequency bands, right? So 5G is being built out on kind of low band for wide area coverage, kind of a thin layer. And then right now with some of these mid-band frequencies, they have wider bandwidths, anywhere from 20 to 100 megahertz wide channels. And then, millimeter wave was mentioned. It's probably going to have more limited use cases, particularly in the beyond line of sight, because you just don't have the range, right? They just have they'll have typically very short range signals. And some of this is being tested with the OpenGen folks that are on this call. But I think one of the things that will need to be looked at also is when you have some of these higher payloads and you're trying to do video streaming, is there will be, some risk of either using a lot of bandwidth or having more uplink interference. So I think that's something that the industry would probably want to work with you on to better understand, is because it's going to really be situational, right? As you were asking the question of how much bandwidth can you take and can you do stream 4K video? It's sort of the answer is going to be right now, it depends, like where you are, how much traffic's on the network. And I suppose if, in a future world, when if we had a prioritized service for a public safety agency, they potentially could, have a higher priority, kind of like what FirstNet does, right, for first responders. So I think those things are all in the realm of possibilities, but we need to understand so we make sure we're not dramatically impacting other customers on the network. So thanks.
It's good hearing from CTIA. It's been a while, but we've worked quite a bit with folks in CTIA to get to this point. And I think one of the, I think what Chris was saying, Chris, you can correct me if I'm wrong, but we're getting more power put out of a cellular system than we are out of a Part 15 unlicensed device, I think is what we're talking about. So a lot of stuff out there right now is just Part 15 transmitters where we can push more power out of a cellular transmitter. Is that what you're saying, Chris?
Oh, no, I misspoke. Yeah, thanks for trying to save me. Yeah.
That's the way I understood it. So
yeah, we get more out of cellular than we do out of Part 15. I mean, still UAS operators in the air, they have the same limitation as a cell phone does. So I think we're talking like 3 watts of transmission from the aircraft over cellular, but cell phone towers themselves can put out up to 100 watts. I wasn't aware of what if they had the same limitations for 5G towers as they're implemented in an urban environment, using those different technologies, especially as they're going up into the C-band using higher frequencies. You require more power to propagate a higher frequency the same distance as you would of a lower frequency. So I was wondering if they were going to offset that by increases in power, or if that would just get to the point where we start frying human beings in an urban area, which we don't want. True microwaves, we don't want, just the energy. So that is a question that I often pose.
Yeah, it really depends on the existing cell density of the operator's network, whether they can go from like a 2 gigahertz design, say for AWS or PCS type design, and then accommodate something that's, you know, in the mid band, say around, you know, 3.5 or 3.7. So they might need some additional sites. Some of that might be offset a little bit by some of these new antennas they call massive MIMO antennas. But in some cases, it might need some additional sites. I think the power limitations are already spec'd out by the FCC, so they were limited in power there, particularly in urban areas. And in some other rural areas, there's different power levels that are allowed. But I think somebody else had a comment or question.
Yeah, well, it's maybe just build on what you said, Tom. This is Ajit. So yeah, it's power is not the end goal of a cellular system. It's the amount, because that just causes other problems. So we're always in power control mode, right? We want to radiate the minimal amount of energy required to meet the requirements of the application. So power in itself is a way to solve some problems, but it creates other problems. So Tom's comment about MIMO antennas, where we can put power in beam format and aim it strategically at a spot or towards the UE, is very important, versus just putting high power to a large area, because that just causes other problems where we deal with interference and no dominant server. I think as the technology is improving, we're getting better at putting power where it's required and minimizing it where it's not.
And Leila, you had a question as well?
Not a question, just a comment. I wanted to add to something that Tom said as well, and he mentioned that we are looking at different scenarios of bands, and so this is one of the areas where we are going to have the opportunity. It's a great opportunity to experiment with mid-band and lower band and a millimeter wave band, and so. Yes, we expect, let's say, of course, a smaller range with millimeter wave, but it may surprise in the sense that the drones are above the clutter, right? So there may be more line of sight than expected, and with beamforming that was just being discussed, we may have a chance to maximize, let's say, signal and minimize interference at the same time. So we are looking forward to having results on that. And that's one of the doors that is opened by 5G that is not there with LTE. So just wanted to highlight that part of the experimentation we are planning will be on millimeter wave.
I have a question on a limitation that might be associated to 5G. Since all cellular networks, they've all been built to support terrestrial users. The reason that we're able to use UAS in this fashion is, you know, accidental. It is the side lobe energy that's just radiated from emissions. Does 5G, with things like its beamforming or with its new technologies, limit, I guess, the propagation of side lobe energy does a 5G tower emit as widely up into, you know, secondary areas as a 4G antenna does?
I would say this will be a question more for the network operators on how they are going to be designed. What we expect is that it could be, I mean, we could be serving high up there, but I mean, I don't know. It all depends on the network design. That's my answer. But the others in the call may be able to give you a better answer in terms of what's coming.
We're leveraging an incidental, an accident
Right.
at the moment. I mean,
Yeah.
but as technology gets better, we start fixing our problems with technologies. And if we end up fixing that one with 5G,
Yeah,
then UAS doesn't have an operation on 5G.
right.
So
But
in
Chris, I
millimeter
think,
wave, oh,
Yeah.
sorry.
yeah, I was going to say, Chris, you do also see the fact that you're seeing lots of handovers because you got too many side lobes, right? You mentioned that yourself. So I think control over the energy and where it goes is something that's beneficial in general as we scale the UAS environment where there's more and more drones in the sky. Then we have to be more careful about how we radiate energy.
Mm-hmm. And that's also the hope that the future network, as the UAS industry grows, if they do leverage cellular more widely, that the cellular networks, the MNOs, will do something with their towers that do help support that function. Because again, at this time, we are leveraging a consequence of radiate energy, not a utility of it.
Yeah. Yeah. I think Paul was about to say something. Sorry. Go ahead, Paul.
I was just going to clarify that operators will typically deploy the higher bands a bit lower, so millimeter wave typically at street pole level. And so, yeah, you won't benefit from that. And the comments are correct around MIMO being, you know, using beamforming to compensate for the less efficient RF propagation at higher frequencies. So I think that's a great observation, though, Chris. That as technology gets better, you'll actually benefit less, right? Because they're going to control all that leakage that you're sort of, you know, riding. But I think overall it benefits us to think of how to fly, you know, drones in, you know, things that are using high bandwidth at lower altitudes. We've done some studies around uplink interference. Uplink meaning like from the drone to the cell tower to send video. It does contribute to more interference overall into the network. It won't be like so destructive that, you know, let's say your partner through Skyward observes an issue, but it does create more interference. So flying a bit lower, it will be helpful from that perspective. So maybe that's something to chase, is that can we do it safely and benefit from better coverage and less interference by flying lower?
Luckily, the network actually works to our advantage a little bit because 5G deployment, you know, is more robust, more likely, at least in the initial term, in urban areas where if we were to go with functions in urban areas like package delivery, they would most likely be at those lower altitudes.
Right.
And as you get into more rural areas, that's where you get up into higher areas, surveillance and long line linear infrastructure. So
And it
helpful at the moment.
automatically corrects itself, right? Because in rural, you're likely to use lower bandwidths with higher towers. And so it's sort of a self, you know, it matches up what your needs are with the network design. So that works out.
I'm curious if the antennas and the network gets more efficient to the point where we're not being able to take advantage of the side lobes like we are now. I'm just wondering if there's a business case out there. Is the network operators, would it be to their advantage to tilt the antennas up a little bit to get a little more altitude, or is that just something that ain't going to happen?
Tilt, no. Add an emitter, yes.
Well, if you pay your
Well,
bills, you're
then again-
another valuable user. So I think that's so good. No, but you know, the other thing is MIMO, multi-user MIMO does work by aiming the beam steering to the different users. So being high up isn't necessarily bad as long as you're within sort of the desired coverage. You actually will not interfere that much, and you'll get they'll be able to cover you and provide service to you as well as anyone else, right? So it's not as bad as you might think. So I think it's just really working together. It's fortunate that Skyward is you know, part of Verizon, so they'll have a voice as well.
And I would like to point Sorry, go ahead, Tom.
Oh, yeah, I think the only way you really know is to sort of look at like, in a simulation, look at a network design, an actual network design of 5G and where you're planning to do a UAS operation and say, look at where they're deploying 5G and what bands and see, what sort of coverage you would have, what kind of interference you would have, how much handover, because it's going to be very, could be very, specific to where you're operating and which operator you're on and what bands you're trying to be on. So, and there's only certain bands that currently authorized by the FCC. So there's a limit right now on which bands we can actually that are open for UAS use. So I think we probably have to work with the FAA on that.
Well, under 4G, you're allowed to use all of the bands except for band 5. That's the 800 megahertz band.
Yeah, we have we've been working with the OpenGen folks on a matrix, which shows all the bands and what their the opportunities are and what the restrictions are.
Mm-hmm. And we're doing our testing, and one of those metrics is specifically to state which band. And one of the testing requirements that I have for the programs that we run on it is to specify the amount of time and what areas in which you operated on what bands, whether it's 2, 8, 12, 15. Yeah, I mean, as far as the FCC was concerned with this and cellular utilization for UAS, all they asked was that we stand away from band 5 and remain within power output limitations. Other than that, they were pretty laissez-faire with it.
Yeah, as long as you're working with a mobile network operator, they don't want any rogue operators.
Is that band 5 limitation, is that due to the legacy, was it part 83? I forget what the part restriction was from the old analog cell days in the 800 megahertz band. Is that still the case, or are there other reasons why band 5 is limited today?
I think it's the allocation on the chart where they did not want to have it relisted for an open network for this. They're actually quite sensitive about that one when you try and dig into it a bit. It was the only restriction they gave us on the entire thing. So we kind of just said, okay. And so far in the companies that I've worked with on this, because not all of them even use band 5, I think only Verizon and AT&T touch band 5. Or maybe it was T-Mobile, I forget. But it hasn't been an issue telling them to stay away from it. The big thing really comes down to the UAS operators and making sure that their firmware is calibrated correctly to only leverage the correct bands. And we have seen some cases, in some areas where there was a bit of a band flow where it was calibrated for, let's say, band 6 and 12, but somehow it flowed over to 8 or band 5. So they had to make some corrections on that. But yeah, that's really the only ground rule that we have from the FCC for these operations.
And I'll send out another call for questions. Anybody with questions about how the FAA is handling UAS communications and integration?
Yeah. Hey, hi, Chris. Jeff Brunig with MITRE. I lost my connectivity just as you were getting into your slide with metrics and everything, and just jump back on. Are you going to share your slides, or specifically the slides on the metrics you've developed?
I can only share it with 31 people, so all the other people in this meeting already got a copy, Jeff.
Okay. Yeah.
Of course, it is universally available. If the group on your team doesn't have them, I can send them out again, or Brian is hosting this meeting. If you like, I can just send it to you and then can put on the distro for the group.
Absolutely, yeah, we can distribute that out. That'd be fine. I believe I already have a current copy that you sent within the last few days. So
okay.
Well, that would be great. Good stuff, Chris, and I appreciate it. Thank you.
Yeah, good to see you again, or virtually, Jeff.
That's right.
And Paul, I believe from Erickson, do you have a question as well?
Yeah, the question in terms of when you guys are testing, do you look at, for example, let's say bandwidth does become constrained. Do you look at what's the minimum frame rate or resolution that you would advise would be considered safe for FAA? Like, let's say you allowed beyond visual line of sight and the pilot had to look at the camera, right? Have you looked at be below a certain frame rate, you think it's unsafe because you can't see enough, or anything like that?
Great question. For the current operations that we are doing, we're focused solely on CNPC. So only on the C2 aspect, not downlinking any of the video trends. As far as I know, those types of regulations requirements don't exist from AIR yet. I mean, that would be part of a TC for those types of systems if they went that far.
Let me just break in there a second. So AIR is the aircraft certification branch within FAA, and TC would be type certificate, correct?
Yes, thank you. Sorry, acronym soup. FAA is
No
worse than DoD sometimes when it comes to that. We keep recreating them and changing them. Yeah, as far as the frame rate things, I mean, I wish everything would be 60 frames per second. Why not? As far as that goes, I don't know, because flight standards is the one that makes the rules as far as safety of flight. So, and as you all very well know, many times when you go for a waiver, it's still kind of the bring me a rock aspect, because there are not the regulations written around that one yet. So it has to do with how much safety of flight is dependent on that. But if you also remember, in the regulations, it has to be with a view that is unaided, you know, the RPIC site. So that's why our current BVLOS operations, for the most part, still have like VOs at distance and things of that nature, or in controlled environments.
And some of this, you know, with the testing, at least from my point of view, hoping to see, you know, what is the minimum acceptable performance that will still allow safe operation, so we can put that into a standard. You know, there's some things that we just don't know yet, and we'll see what we can do and still safely operate. Somebody's got a hand up out there.
Charles.
Yes, go ahead, please, with your question.
Yeah, I just wanted, it's not really a question. Well, I guess it is a question. One of the key issues is going to be latency for public safety. Is what is the signal? What's the latency? Because if we're doing a SWAT operation, obviously 3 to 4 second delay is the difference between whether you make the right shot or not, as well as on hazmat stuff. So I just wanted to bring that up.
And that is one of our metrics, and we use it. Luckily, over the cellular network, the heartbeat signals are like 10 of them per millisecond. Right now, for most programs, I always recommend, and this, again, this is just for C2, we recommend a 10-second latency before you initiate things like return to home or land immediately. That is not law, that is not legislation. It's just a recommendation, but highly dependent on the environment that you're operating in. So, but you're talking about latency for an operation where you have to execute a command based on an emergency need, right?
Yes.
Okay. Yeah, I mean, see, that goes down to an operational requirement for what you do and is less a FAA safety standard. Our concern is safety of flight for yourself and for others. When it comes to the actual operational needs, then that would be based on individual CONOPS.
Yeah, and that's I think we're talking two different things there. One is, you know, at what point do you execute a lost link? And the other is how much latency can you perpetually put up with and still operate? I know that's a real issue when you start doing voice communications and you're talking to air traffic controllers, and if there's a gap, that just means that the next person starts talking, and that's the kind of stuff I think you're talking about that can be annoying and maybe even unsafe in an emergency situation. But I think we've been seeing pretty good, you know, low latency numbers in our testing. It's much less than what you'd see with a SATCOM, and even SATCOM. Some of those systems are doing all right.
Mm-hmm. Yeah, we've actually had very good results so far.
Oh, that's especially with, you know, satellites being so much further away. That's encouraging news as well. But Charles, did you have a follow-up question, or are you all set?
No, I'm set. Just didn't take my hand down.
Okay, thank you. Ajit, go ahead, please.
Hey, I had a follow-up question to you, Chris, before you talked about some of the detect and avoid areas. And I'd like for you to expand on what you're looking at from the cellular network on the data you're collecting on detect and avoid.
We're not looking for anything specifically on detect and avoid. For the most part, detect and avoid is a function of sensor and downlink from this nature. The current program that we are partnered into, where it is an actual contractual requirement, is to look at the data points that I gave you or that are existing on the spreadsheet. So it's not taking into account sensor downlink information yet for DAA. And I think the question you're asking does go to a much larger thing, you know, what is the FAA's DAA standard for, you know, how quickly do you need to be alerted? How quickly do you process it? How quickly do you react to it? So the much larger mathematical computation that takes place that is not necessarily just a product of C2, but of the technology and the wiring. I'd be happy to talk about that. That might be a takeoff of this call type of a topic, though, because it can go down a few holes.
Right. Yeah, and the reason I ask is we are looking at some experiments around detect and avoid with OpenGen, and we'd be really interested to understand what would be valuable in that space.
Absolutely. Yeah. I mean, my other side job is DAA, so I'd be happy to talk with you about that.
I guess that raises another question along the DAA stuff. Realistically, isn't it going to be like a systemic approach of how you use DAA? So it's not just on board, but it's collecting other data and coming into a systemic type of way of achieving DAA?
Again, it gets complicated. That's a 2-hour conversation in itself. So it all comes down to safety case is the bottom line from an FAA standpoint for what we care about. What is the safety of your flight? After you get past things like, does your plane fly? How often does it crash? To put it simply, if I was an AFS person and, you know, doing waivers for safety of flight, I wouldn't care if you had the worst C2, the worst DAA, and the most crashed aircraft in history. As long as you present a safety case and the ConOps of your operation that say, we know this plane crashes every 5 times, but we're going to land it after every 1 time, dispose of it, and build a new one. So it really, chicken and the egg doesn't have to exist for this. What we like looking at is seeing people who evaluate their environment, seeing what they actually need for it to create a safe flight, and then build the safety case around that. When it comes to DAA and C2, as soon as your DAA becomes a function that is transmitted from your aircraft rather than ground-based, or relies on your ground-based transmitter to send something up the aircraft to give a command, then C2 becomes a critical node. If you have DAA on board that is an automatic function where, let's say, it detects something, it knows to get out of the way and land immediately, then your critical node is your flight controller and the mechanics that you have on the aircraft. Show a safety case that you can do this up to a certain percentage of reliability, and that's what supports the safety case. The problem is we just don't have that number to give you to say you must stay this far away, you must land in this many seconds. That's where I think everyone is still in kind of the collecting phase when it comes to data.
Another aspect of that question, the answer is the it mentioned operations in a UTM and how this could be essentially the backbone of a UTM network. That if you've got sensors, ground-based sensors, airborne-based sensors, they can all serve as a node feeding into the network, and so every aircraft around you can benefit from the fact that you've got a radar out there and they can see what's in your bubble anyhow. And if there's enough of those in the network, you get more dense coverage and can kind of help each other out. They all act as somewhat of a supplemental data service provider.
Well, thank you for that. I'll just have one final call for questions from anybody who would like to ask questions. But Art, Chris, would you like to ask questions to the group at all? Anything that you haven't covered before that you're curious about where industry is heading, or that our members might have some more insights on?
I have about 400 of them, so if you'd like to extend the meeting. I mean, my biggest questions really has to do with 5G rollout, the technology, if there will be modification to the towers on how that energy is propagated. So if we have to relook at how we're modeling this, or if it will follow suit with what 4G has emitted, obviously as you move from different protocols, CDMA, ODMA to the new levels, is the propagation pattern significantly going to change to the point where we need to augment how we look at data or how we conduct testing? That's probably my biggest pose to the group.
The data is the big question mark right now. How can we get that data, and how can that inform the regulations?
and making sure that we're collecting the right forms of data, because everything that we do right now is based on a calculus of understanding. 5G is a completely new dimension for cellular. So if it is changing that calculus, we need to know so that we can augment our existing testing to collect the right information.
One thing I will say on that question, and I don't have the answer to your question, of course, Chris, but just to add a different dimension to that, is that the answer also depends on whether we're talking about a private network or the commercial network, right? So there may be situations where the network may be, I mean, very focused and optimized, like think of agricultural or some separated environment where 5G as a technology can be leveraged in its full extent with, I mean, and dedicated and focused on drone operation, which may, I mean, it's totally different from the question on business case that Art was asking as well. So it depends also, I mean, just to add the fact that there are possibilities for private networks, and that will be different.
Absolutely.
And my request, the same thing I put out there before, any golden nuggets anybody has on how the attributes of 5G can be useful to us to enhance safety of the NAS with UASC2, you know, send us your cards and letters. We'd love to hear it.
Andy, go ahead, please.
Yeah. First, I guess let me put my hand down just so that it doesn't look weird. And I still failed to do that. First, thank you. This has been great, right? I've been listening in, and I unfortunately I've kind of been a little bit on and off, but I wanted to make sure to ask this question. But first, shout out to Chief Werner. It's been more than a minute since I've been on a call with Chief Werner, so it's great to see what he's doing in the first responder drone space. But have you guys, you know, when in looking at some of the answers to your questions, obviously interacting with industry and OpenGen and everything is an easy conduit, right, to take advantage of, given what you've set up with this meeting. But have you looked at engaging in 3GPP? You know, I think. Okay, and yeah. You know, do you know, like, how deeply are you? Are you like working on service definition, right, in S1? Are you trying to drive, you know, your requirements? I mean, because we can certainly talk about all the things that 3GPP is capable of doing, but I think certainly looking at the gaps for what you want that isn't there, right, is something that the industry would certainly be interested in, given that they've, you know, been developing standards in this space.
Absolutely. We're actively involved in ACJA, and Barbara Peregolo and her group, and then formally with GUPMA before it evolved. I think Thomas Neubauer heads up one of the group. We've got Boris, who was heading up the other one, and now I think it's Stefano from Qualcomm. But looking at those groups, we are not, well, I guess because I'm the person on it, so I can say I don't directly contribute to changes in it because that technical level goes to a level beyond me. I contribute mostly in the wording and the augmentation that fits in with the FAA spectrum, dual use word there. So that would actually be received well. I do like all of these different groups, and, you know, of course, what's going on with DO 377 Alpha, and as we are adding to it, I just always throw out a cautionary tale here, because again, this is chicken and the egg. How can you write a regulation without understanding the capabilities and limitations of the system? So my main focus right now, 99% of my energy goes into acquiring as much varied data as possible to be able to speak in front of these groups like 3GPP, GSMA, RTCA, and say, here's what we know is possible, here's what we know does not work. Now write a regulation around that. But yeah, if there are other groups that are involved in this, I would love to hear about it. And if they want our participation, and I'd be very interested.
Well, I feel like, you know, one of the things that I've at least seen, you know, working across various departments and agencies is just a whole lot of common interest, right? I mean, obviously, you know, FAA's interest in UAS, Department of Defense, right? Same thing. DHS is also interested, right? So there's a number of different agencies that are all kind of looking at in similar places, you know, where you may be able to pull resources to try to pull more oars in the water, right, to get stuff done that you want to get done, right, and maybe leverage somebody else's, you know, subject matter expertise, right, to get your gaps addressed, you know, along the way. So just food for
Yeah, I am open to as much information as possible. Think of me as Johnny Five. Input is my way. Every one of these meetings I get on, I ask the exact same question. Please tell me who is testing out there. Where is there more data we can get our hands on? And we are open to partnerships left and right.
Roger that. All right. Thank you for answering the question.
Thank you, sir.
Well, with that, I believe we are at time. So I would like to thank Art and Chris for joining us today and just sharing your insights. It sounds like there's tons of things going on, tons of questions that you would like more information on with industry as time proceeds as well. So we hope that you will remain engaged with us. And we are here. I'll also be sharing that spreadsheet to the group of information. And for the Open Gen members, I just want to flag that we are working on our next Open Generation Government Liaison with a state aviation organization that we hope to announce in the coming weeks. And so we'll get the time and dates to you as well. Ajit and Leila, do you have any closing remarks?
Yeah, I have one. I'd like to remind everybody next week is AUVSI, and Leila is going to be hosting a panel on Wednesday with New Air, Verizon Skyward, and Nokia to talk about 5G and UAS during the show. And we'll also be at the MITRE booth and throughout the show with myself and Kevin Moran. So if anyone is in Orlando next week, we'd love to see you. And we hope you, for all members and participants, if you would join and support Leila at the panel, we'd appreciate it.
Thanks, Ajit. And will that panel be available online as well? I know AUVSI has dual, or it's not hybrid, it's in person only. Okay.
And I think this one's in person unless, and if you buy the ticket, maybe you can see the results afterwards, possibly. I'm not certain myself.
And I have to add, it's a big thank you for Art and Chris. Thank you very much. This was very informative. I mean, really enjoyed the discussion, and I'm sure the members have as well.
Happy to help.
Thanks for having us.
Yeah,
Enjoyed it.
thank you, Art and Chris, as well for myself.
Thank you so
Thank you.
much. We really appreciate your time and your expertise in this area. With that, I am going to close today's roundtable discussion. Thank you to everybody who joined today. We appreciate your attendance and look forward to seeing you at our next government roundtable event. Until then, take care.
Thank you.
Cheers.
Bye-bye.